Hey everyone, welcome to our next lesson, The Ocean in Motion. This is the beginning of Chapter 2 for Unit 6. At this point, you should have already read the article, The Ocean in Motion, and this should almost be a second viewing for you. To get started, I want to go into the warm-up, and if you haven't already, I would open up the Amplify site that I had sent to you that links you to the warm-up question. And what they're asking you to do is to find where you live on the map and estimate the latitude and answer the questions below the map. So normally when we view a map, we actually view this in a different direction, that we have the US over here and Eurasia over here. But essentially, it doesn't matter as long as they're connected, because this is actually a circle. This would be a sphere shape. So it's just choosing what part of the world you're making the center of the map. And normally we have the way that we view the map is pretty typical. Let me just look up world map to show you that typically we see it as such, with the US on the left and Eurasia and Africa, Australia on the right, is because the people who made the map that we use for navigation was actually England, and they just made themselves the center of the map. That's just what they chose. So, but if we go onto the Amplify site, they actually are choosing this part of the world to be the center, so it'd just be continuously moving over. And if you have any questions about that, you can look up a movable map and you'll see that it can go around and around and around. It doesn't make a difference what is the center. So some key points here is we have the United States here, Canada, Mexico, South America, Africa on the tip over here, Australia, Eurasia over here. This is also part of Europe, right above Africa and such. And the question asks us to find where we live. And we live actually right here. So here would be Florida, going up, all the way up, this part being the top of the United States. We're right about here. We're actually pretty close to 40 degrees north. And we can also Google what latitude is New York City, and we are 40.71, so almost exactly dead on to 40 degrees north. Again, north. We are west because we are west of England, England being the center going for the up and down ways. So again, 40 degrees north. Based on the latitude, so we're going to put 40 degrees north. And it asks us this, based on your latitude estimate, predict how much energy is transferred from the sun to the surface and then to the air in your city. So if we know this is the highest point of energy, this being medium, this being low. We're kind of just on the border of medium and low. But since we have pretty warm summers, I'm going to go on the medium side just because we do experience a full summer. We have a medium amount of energy transfer. And how much of the energy is transferred from the sun to the surface, and then to the city. Again, during the summer, we have medium high, and winter, medium low. Since during the winter months, we are tilted away from the sun, getting less energy. Now, other than latitude, what else do you think might affect the air temperature of where you live? what we don't really talk about very often is that we live by water. So if we think about our last unit about weather patterns and what water does and how it affects temperature, when it rains, it cools off some bit and also lowers some of the humidity in the air. So something that might affect temperature might be the water. We live by fresh and saltwater sources for rivers, lakes, and most notably the ocean. So after that, I would like you guys to press hand in. And I'm going to return back to our slideshow here, which is still on the warm-up slide. Now the next part is actually the reading of the ocean in motion, which you should have already read. So I want to go back to our unit question. What determines the air temperature of a location on Earth? In chapter 1, we noted that the closer a location is to the equator, the more energy it receives from the sun. But this can't be the only answer, because we know that the closer a location is to the equator, the more energy it receives from the sun. But both the air temperature and ocean temperature in Christchurch are cooler during El Nino years. Since a city's latitude does not change, the cities might grow and expand over time, but the location is the same. We need to consider factors other than latitude. So we need to think about things outside of just simply where they are. And that brings us to our chapter 2 question. Other than latitude, what else affects the air temperature of Christchurch? So in our first chapter, we learned the main thing is latitude. Now, since there's a change inside of this city, we want to know what else can affect the temperature. Now, if we look here, we have the cause and effect, and our question is, what determines the location's air temperature? Here we have an effect. A location's air temperature is the effect. What happens? And one of the first causes that we got from chapter 1 is energy from the sun transferred to the Earth's surface. Some of that energy is then transferred to the air. So the cause is a location's latitude. But there must be something else, which brings us to the point where we can think of an air temperature of a location as an effect. The air temperature is the result of some cause or causes. And we are trying to find out what those are. We know that latitude affects the air temperature, but this does not explain why Christchurch is cooler during El Nino years. There must be some other causes. So an effect may have more than one cause. These may be linked into a chain of causes and effects. Cause and effect is a big science concept, and normally when we think of cause and effect, we think one thing caused another. But as we learned from the last unit, a weather pattern, that sometimes we need multiple causes to have the effect that we are reviewing. And this seems to be more true in this unit as well with the El Nino, right? It's not just the latitude. There has to be something else. So in the last 2 weather units, we're learning that weather is an effect of multiple types of events. So let's go back to the chapter 2 question. Other than latitude, what else affects the air temperature of Christchurch? The amount of sun didn't change, but we did have a change in air and ocean. One way air gets energy is when energy is transferred from the ocean to the air. Over the next few lessons, we will focus on ocean temperature to see how it might affect the air temperature of Christchurch during El Nino years. And we already got evidence in our last lesson that there is a change in the ocean temperature. So we're going to look in ways that this could have an effect. Now, in the last lesson, we talked about the letter that we got from Kira Patara, the director of the New Zealand Farm Council. And she sent us that article, which was the article that you should have already read, The Ocean in Motion. And I want to talk about some key parts of this. And before we keep going, I want to show you this video that's from the NASA. Hold on, let me undo this. And what we're seeing here is actually the currents of the ocean going around on Earth. Notice that there's different kinds. These kind of flow for a longer time, whereas this one kind of just goes in a simple circle. Again, a simple circle. And this one kind of flows into many different areas. Again, the yellow line being the equator. Look how fast these are moving and how many are moving. So at this point, I'm going to go back to Amplify and go on to the article. You can use the PDF or the article online. It doesn't make a difference. And I want to point out some key things here. The ocean in motion. Right away, I know that we're going to be talking about the ocean moving, which sets me to... It already sets the stage that the ocean moving might have something to do with what's being taken with it, including temperature and other things. In this article, it goes over pretty much how these shoes fell off a cargo ship and they landed in multiple locations. Even after reading the first paragraph, I thought about Oregon, Hawaii, and Japan being in completely different locations, and how that might play an effect that if one area is really warm or really cold, if it's going to multiple places, it can have an effect on multiple parts of the world. So not only multiple causes, but multiple effects. And I want to go down to here where we talked about the major ocean currents. Some seem to flow just straight across, but these blue lines show cold water. And notice how it comes up and comes down. And also the warm water has channels that push it out and push it out to the top and bottom. So I'm starting to think if it's not the amount of sun that changes, and I'm getting information about currents and temperature and how the ocean can change the air temperature, if the ocean has different currents or changes currents even slightly, this could be an effect that causes temperature to change. Here at the end, it says the maps make it look like oceans are constant. However, oceans constants can sometimes change direction. I'm going to highlight that because we're looking for something that changes. And if this is a possible change and currents are linked to temperature, this might be an answer or some part of an answer that could help us understand why during El Nino time the temperature is different. All right, so what I need you guys to do again is reread this article. Again, you can read it on here on Amplify, or you can read it on the PDF. Also, please note that you can switch the whole thing into Spanish, and on here it'll give you the article in Spanish. And we're going to talk about this this article one more time tomorrow, and it's going to help us get some information about what's going on in Christchurch, New Zealand. See you guys soon.